Hello, everyone. You are welcome once again to today's lesson. Today's lesson, we are going to continue from where we left off on the topic rational functions and partial fractions. Okay, in lesson 2, we were looking at how to resolve rational functions into partial fractions. Okay, we looked at a situation where your denominator, okay, contains direct linear factors, a quadratic factor which will factorize into what do you call it, linear factors, and how to write the identity and move from there to resolve. Okay, so today we are going to continue in that same lesson 2. Okay, you realize that this was one of the questions we started. We got here and I asked you to go and continue. However, okay, because some of you just joined, okay, I'm going to give you the opportunity to at least get all that you are supposed to get or you were supposed to get from the previous video or previous lesson, okay, here as well. Because if you are not able to deal with the linear situation, I can assure you any other situation you will struggle. So meaning the linear situation is the simplest in terms of the resolution. So now, okay, I'm going to take you through this again. You know, okay, with this one, what do we do? Proper, degree of the numerator 1, that's of the denominator 2, so it's a proper. That's the first question. Second question, your denominator, okay, contains only one factor. Okay, this expression, any expression sitting in the denominator is taken as what? As a factor. So this is a factor, okay, however, this is a quadratic factor which could be factorable. So let's see, on the face of it, can we get factors of 8? Okay, because the leading coefficient is 1. Factor pair of 8, that's when we add, you get minus 6. When you multiply, you get 8, yes. And that will be minus 4 and minus 2, or minus 2 and minus 4. So on that note, we know that this is factorable. But because this is a special situation, like I said, okay, you can directly factorize without going through. And that's the trick. X first, your variable, the second bracket, X will start. Okay, you close it. Now the factor pair will be minus 2, minus 4. So you just come and write minus 2, minus 4. And that's exactly what you have here. So after that, okay, now that your denominator factors, none of them is factorable, you know that, okay, we are going to get two fractions. Okay, what the denominator here will be the denominator of one of the fractions. The factor here will be the denominator of, okay, the other fraction. So in this case, okay, my first denominator, x minus 2, linear, its numerator will be a constant, plus, okay, second fraction, denominator, x minus 2, okay, linear, numerator, a constant. But you know you have introduced letters here, so you knew you were going to introduce letter, therefore it will be the identity, so you use the identity symbol. After that, equal to, take the single fraction of this, so LCM will be this times this, and I've told you LCM will always be the non-factorable factors that you have here, so you bring it here. Then after that, x minus 2 will go into the LCM, x minus 4, then times A. Okay, then the B, okay, what do you do? This one will be plus B. The number of times this will go into this, and that will give you x minus 2, so it will be B times this. Okay, at this point, okay, the denominators here, okay, are the same if you look at what you have here. So you just come and equate the numerators because the numerators must also be the same. And that's exactly what you have here. So because all your factors are linear, ideally, okay, we are supposed to use the cover up method or the elimination method. So here, okay, you can choose to cover up, okay, the B. In that case, it means this factor, you want to eliminate B. So for B to be eliminated, this factor here must be set to 0. It should be 0. So set it to 0 and solve for your x. So x will be equal to 2. So it means do that mentally. If you want to write it, don't let it be part of your main work. Let it be your rough work. Take notes. Okay, so at this point, you come and write if x is equal to 2, not when. Okay, that's not to say that if you write when, you'll be marked down. I will underline that because I've given you ways to save time and protect our marks. Okay, so you substitute wherever you see x here, it is 2. You substitute. And always this will be too short to take a line. So don't come down. Write comma and continue. Okay, so at this point, we are going to get 16 minus 28 is equal to, okay, this and this will give you minus 2. Okay, so minus 2 times A, minus 2A. However, you know that this will vanish. So at this point, let's continue. Okay, so what do we get here? 16 minus 28. And once this kind of calculation, you know you will do it. Okay, so I'm waiting. So that negative
12.
Okay, 12 is equal to what? Okay, minus 2a. I write it again before I divide, but I'm going to do that here. So negative 12 is equal to, okay, negative 2a over negative 2 over negative 2. Okay, so this gives me, I'm going to write a is equal to 6. Am I right?
Yes, please.
Okay, so we go and cover, okay, use the second linear factor. Okay, so you cover this, which will give us what? Okay, for this to be 0, you equate this one to 0. So x will be equal to 4. So you write if, okay, x is equal to 4. Okay, it will be too short to take a line. So you continue here. So that will give us 8 into 4, okay, minus 28 is equal to a, wherever we see x here, it's going to be 4 into what? 4 minus 4, okay, plus b into, okay, and that will give us 4 minus 2. You close it. Okay, so at this point, what do we do? 8 times 4 will give us
32.
Okay, so you are going to get 32. Okay, 32 minus 28. So you can use your calculator to give us this straight away so that we don't waste time.
4.
Okay, so positive 4 is equal to, okay, this will be a. You know that you use this factor, so you wanted this to be eliminated, the a. So it's eliminated. Don't write a into 0. Okay, it will give you, then this will be 4 minus 2, which is 2, times what? B. So that will give us 2b. Okay, you write it again, then you divide. So this time I'm going to write it this way and divide. That doesn't mean I have moved. Okay, so over 2 over 2. So b will be equal to what? 2. Okay, and please take note. You don't draw your conclusion. I think I should have addressed this, but in any case, I'm addressing it here. Somebody is concerned. Okay, you don't draw your conclusion with A and B. The question didn't ask you to find A and B. The first question asked you to write the partial fraction form of the rational function. So your conclusion should be at the point where you are writing, okay, that. Okay, A and B basically are means to, okay, an end. So at this point, once we know, we can go and conclude. So therefore, okay, whatever that we were asked to resolve, which is what? 8x minus 28 all over, okay, your x squared, okay, minus what? 6x, okay, plus 8, okay, will be equal to, now that will be equal to, we said A. Is A positive? A is positive, so you can start with A. So that will give us 6 over, okay, x minus 2. Then plus B is also positive, so 2 over, okay, x minus 4. All correct, my professors?
Yes, please.
Yes, sir.
Okay, so I think at this point, okay, with the linear situation, okay, we should be able to deal with it. So whether your rational function came with the denominator already factorized, okay, or, okay, where we need to, okay, factorize, we should know how to deal with that. So on this note, okay, we as for the D, I will, okay, allow you to do it later just to save time. Okay, so the E as well, you try. Okay, is that okay with you? Is that fine with you?
Yes, sir.
Okay, so we are going to move on to, okay, the second, okay, worked example. All right, so here we are going to do a little more work just in terms of our algebra, but the concept basically will be the same. Okay, so you can see that if your identity, meaning writing, okay, rational function into the corresponding identity, if it is weak, okay, you should know your resolution as well will suffer, because you cannot, okay, resolve without going through the identity. So that's the more reason why we spend time on the identity, because I knew, okay, that held a particular key, okay, to the future. So at this point, quickly, okay, resolve the following into partial fractions. So usually you'll be asked to resolve into partial fractions. So there is nothing salient here to underline. If you want to maybe resolve, okay, then you know you are ending, okay, at the partial fraction, not at the identity. So then what do we write? Okay, at this point, okay, major question number 2. Solution is what you write first anyway, you should know that. Okay, so major question number next. Okay, our minor question number A, then we extract, so what we are asked to. So at this point, okay, let's see. Your fraction here, is it proper or improper? That's the first question. Degree of the numerator is 1. The degree of the denominator, this is 1, this is 2. So the degree of the denominator will be 3. So 1/3 is a proper fraction. Am I right?
Yes, please.
Okay, so on this note, we know that's proper. So once it's proper, then we can move straight away to the denominator. So when you come to the denominator, okay, which is your next point of call, you ask yourself questions. Okay, my denominator that I have there, how many factors? Okay, I have 2 factors, this factor and this factor. But before I can write the identity, okay, my factor should be explicit. So meaning if I have any factor which is what factorable, I need to go and factorize. So this is a linear expression, obviously, of factor which is not factorable. This is quadratic. Okay, it's not factorable because, okay, if this was minus, then we could have used difference of 2 squares to factorize. But if this is plus, okay, we cannot. We don't have sum of 2 squares factorization. So please take notes. Okay, so at this point, we are more than good to go. We know the factors, okay, sitting in the denominator, none of them is factorable. So it means we can go and write our identity. So we know this factor will give you 1 fraction. This factor will also give you 1 fraction. So in all, we are going to get 2 fractions. Okay, where in each of the fraction, each of the factors here will be sitting in the denominator. So I will come and write, okay, identical to my first fraction. The denominator will be this factor, x minus 1. Then plus my second fraction, the denominator will be this factor, s squared plus 1. Is my point well made?
Yes, sir.
Okay, now you go to the numerator. So of each of the fractions, because this is linear, yes, my professor? Or you were responding, yes, sir? Okay, so because this is linear, the numerator will be a constant, so a constant A. This is quadratic, okay, and its numerator will be linear, so it will be bx, okay, plus c. Take notes. So at this point, the next step, having written the identity, what do? We come and write equal to. So now, okay, your LCM, and I've told you that it will always be the non-factorized factors that you have there. So the product of the 2. So x minus 1, okay, then x squared plus 1. So this is what we have. Okay, at this point, we should be good to go. Okay, so let me see whether I use an alternative method going forward. Yes, there is an alternative method. So let me see the method. So I'm going to use the cover up. Okay, Prof. Amanda.
Miss Ma'am, please, can you take it again?
From where?
Please, from the identity part.
Here.
Yes, please.
Prof. Amanda, as for identity there, we've gone beyond that. Oh. You should be an expert in writing identity by now. That's the more reason why I spend time there. So if I spend time there and we come here and you still want us to, so you should have cured that, okay, that other than that you are not being fair to the other students. But that notwithstanding, I'll walk you through. I just want you to, okay, take your destiny into your own hands by doing more work. I know you are learning, but okay, make sure all that we learn will build on. So don't let us go back if we have done something. And you know the way I teach, I'll always make sure that going forward, whatever that you need, you have already been provided with. That one I can assure you. Okay, so that, okay, you won't feel like I've given you the short end of the stick. Okay, so now this is what we have. Okay, I said, you should know, anytime you are, those of you who understand, okay, you can continue. Okay, whilst I'm addressing her concern. So it's good you have asked anyway. So at this point, you know, this is linear. So remember, we did a lot of, as for the identity, we did a lot of questions. Okay, complex questions. I took you through all the tricks so that when we get here, the work will be easier. But that's not the story anyway that Amanda is trying to depict. So what do we have? We have the denominator here is linear. So linear, it will give you one fraction, linear, denominator of that fraction. This is quadratic, it's not factorable. So denominator of the other fraction, non-factorable factors, all of each one will give you, so 2 fractions. Then this is linear. Remember, the numerator should be a degree lower than that. I gave you, okay, the table indirectly when I was explaining. Linear numerator, a constant. Quadratic numerator, linear. Okay, so take note. So you know this. So at this point, Amanda, are you fine now? If not, then I will ask you to go and revise. The video is there, so go and revise. Okay, so at this point, what do we do? Okay, you ask yourself, this will go into your LCM how many times? Okay, the whole of this divided by s minus 1 will cancel. So you'll be left with s squared plus 1 times a. So it will be a times what? X squared, okay, plus 1. Then plus, this will go into your LCM how many times? The s squared plus 1 will cancel this s squared plus 1. So I'll be left with this, then times what? The bx plus c. So bx plus c, then I extend it, okay, times, okay, x minus 1. Am I right? Hello, am I right? Do you see anything wrong with what I've written? If not, we move on.
Please, there's something wrong.
What is wrong, my professor?
Please, the bx plus c should also be in bracket.
Perfect. Okay, so take note of this. Okay, so here, okay, because whatever you are going to multiply, okay, none of them, okay, was a monomial. Remember, okay, it must be in bracket. Other than that, the meaning will change. So I've drawn your attention to this. If you do same for me, and I'll mark you down. Okay, don't say I'm not nice. Okay, or I've not been fair. Please take notes. Okay, because I've told you to do the right. I've told you the right and you should know, and you now know, so you have to do it. So you know, if the bracket is not there and you go and expand as if the bracket is there, okay, we mark what we have there. We don't mark what we have in your head. So if the bracket is not there, when you are expanding, it is the c that you have to multiply by this. You cannot multiply this by the bx. So if you do so, it is not reflecting exactly what you've written. So take note. I've pointed, okay, this one out. So now what do? Denominators the same of our 2 fractions. So we equate the numerators. So this implies that, and don't write equating the numerators, though we will know you are equating the numerators. Take note. All right, so at this point, what are we going to get? We are going to get 3x, okay, minus 1 should be equal to a into what? X squared plus 1 plus what? B x plus c in brackets, okay, times what? X minus 1. Okay, please take note at this point. Okay, if you are expert in using the cover up method, okay, any question at all, you can use the cover up method or the elimination method if you are experts, and I'm going to guide you as to how, okay, to make yourself an expert, okay, in using the cover up or the elimination method. Okay, then after that, we'll go and use the other method. Okay, anyway, remember I said, ideally, it is advisable to use the cover up method when all your factors, okay, in the denominator of your rational function, okay, after you have factorized, done all your factorization. Okay, when all your non-factorable factors, I should be more specific, all of them linear, usually it is ideal to use the cover up. However, here is the case, this factor here is linear. Is this linear? Is this linear, my professors? Oops.
No, please.
Okay, so then we will say that maybe that method will not be ideal. I mean, the cover up or the elimination method will not be ideal. But if you are expert, it can still be ideal. And by that, this is what I mean. First of all, your substitution that you have to go for the linear one, because that's the one that you can, okay, equate to 0 and solve. So your first substitution will be if, okay, x is equal to, so let's go for the first value. If you equate this one to 0 and solve for s will be equal to 1. Do you agree? So if x is equal to 1, okay, we go and substitute that one here. We are going to get 3 into 1 minus 1 should be equal to A into what? 1 squared, okay, plus 1, okay, into, sorry, plus, okay, B into 1 plus C, okay, the whole of that into 1 minus 1. All correct. Please, should I come again, or my point is well made? This one is just substitution. Substitute x is equal to 1 in this relation that we have here. Is my point well made? And here I ignore the bracket for the 1, okay, because I realize that if I introduce the brackets, or remember I've told you anytime you are substituting, it's convenient for you to put it in brackets, but I'm more matured. I know that if it is plus 1, okay, squared, okay, the square will not affect anything. If it's negative, then I have to be very careful. Negative with powers, the values can alternate in terms of signs. Okay, so at this point, if you are fine, then we come here 3 minus 1, and that will give us 2. Okay, and that should be equal to 1
Yes, sir.
squared. 1 squared is 1 plus 1 is 2. 2 times a, so that will give you 2a. Okay, remember any factor, any term that contains the factor that you set to 0 will vanish. So here, what do we have? 1 minus what? 1, 0. So irrespective of whatever that you have in brackets here, if you multiply it by this, the 0, you get 0. So that is gone. So in this case, I can write it again and divide by 2. Okay, you could have, okay, kept the 2a here and divide by, okay, I've said more than enough when it comes to this. So over 2. So a will be equal to 1 here. All correct.
Yes, please.
Okay, so we are going to go for that of what? Of the other substitution. You can see that usually it's the linear substitution that makes it easy to, the factor that will make it easy to carry out your substitution. But you've exhausted your linear factors. In this case, only one linear factor. So does that mean you cannot continue? So that's the more reason why we usually will say that, okay, this will not be the ideal way if the other one, but don't worry, it is ideal still. If you exhaust your linear factors, don't worry. There is always what I call, okay, liberty values that you are supposed to go for. Okay, and the liberty values that you are supposed to go for after you've exhausted all your possible linear factors, okay, that you set to 0 to help you do the direct substitution or the known substitutions. Okay, the liberty values that you go for will be 0 if x is equal to 0, if 0 has not been used. Okay, then you go for 1 if 1 has not been used. You go for 2 if 2 has not been used. Okay, some will say that go for -1, but for me, I've told you I don't like negative. So I will never go for negative if I can avoid. So move, okay, 0, 1, 2, 3, what have you. So in this case, this is what I'm going to do. 0 has not been used, so let's go for 0. So if x is equal to 0, let's see what is going to happen. In any case, I can see one of the, okay, with 0, but don't worry. So we are going to deal with it. Then you will know exactly what I'm talking about. So if x is equal to 0, wherever we see x here, we substitute 0. So we are going to get 3 into 0, okay, plus what? Sorry, it's -1, forgive me. Okay, so -1. Oops. Okay. I hope you are following my professors. Okay, so -1 is equal to a into 0 squared. Okay, then plus 1. Then plus, okay, in bracket b into 0 plus c. But that's not all. The whole of that times, okay, times 1 minus 0 minus 1. Am I right? My professors, are you with me?
Yes, please.
Okay, so on this note, this gives me, this side will be 3 times 0, that is 0 minus 1. So I will get -1 is equal to, and you can see anytime I move from one line to the, I write close to the margin. Even the continuation here, I came to write it here, close to the margin. So that would be equal to, okay, a into 0 squared plus 1. So this will give you, what you have in bracket here will give you 1 times a, so that will give you a. Okay, then, okay, plus, okay, b times 0 will give you 0. Okay, then c. So it means what I have here will be c. Okay, so I'm going to write it just for explanation purposes. So see, if you like, you can put it in brackets. But now it's a monomial. Okay, so let me see. This one will give you -1, so -1. I could have done that mentally and written -c straight away. So you are now going to, so this is just for explanation purposes. So -1 will be equal to a minus c. All correct? All correct, my professors?
Yes, sir.
Okay, so now you can see that usually when you carry out your substitution, okay, I should say the cover up method, if A and you are covering up B, B will go, you get your A straight away, and the other one too. Okay, but here, okay, your equation that you have there contains two unknowns, but thankfully, you know A is known. So once A is known, you know you are not bothered. You just come and substitute. So this implies that -1 is equal to 1 minus C. So I will move the C to this side, which gives me C is equal to, then I move this one to this side, is equal to 2. You get a point. Is my point well made?
Yes, sir.
Okay,
Yes,
so we've exhausted one of our liberty values. So the next liberty value should be 1. But here is the case 1 has been used. So we go to our next liberty value, which will be, hello, which will be, oh, I just advised you how to move in terms of picking your liberty values. So 0, 1, 2, okay, 3. 0, we've now, it wasn't used, we've used it now. 1, okay, already used, so you go for 2. So let's see what will happen. If x is equal to 2, comma, we are going, you can see that throughout, I have not left any line because I'm dealing with the same steps. I can only leave a line when I'm moving from a sub-question to another sub-question, but I have not moved. So all lines must be occupied. So f is equal to 2. Wherever you see x here, it will be 2. So it will be 3 into 2 minus 1 should be equal to a into 2 squared plus 1, okay, plus what? B into 2 plus C, then into what? Times, okay, your 2 minus 1. All correct. Okay, later I will minimize this, reduce this and push it to the side. Okay, Prof. Mamiya.
Please, I don't understand the liberty values still.
Oh, liberty values will be the values that you can pick. What do you mean by liberty? So your value of choice, any value.
Any value.
Yes,
So
that's
there's
what.
no order. You
Yes,
just put it.
you can put 1,000 there, but you know that if you put 1,000 there, your work will be difficult. So that's why I said
Yeah.
move in that direction. 0, 1, 2, 3, what have you.
Okay.
Okay, all right. So now so you get it now.
Yes, please.
Okay, so now what do we do? Okay, I'm going to do this so that you know that it's not part of this. Okay, so this implies that, okay, or you can choose not to write the implication. So 3 times 2, 6 minus 1. So that will give us what? 5. That should be equal to 2 squared 4 plus 1, 5 times a, 5a. I hope you are following my professors. Oh, I've seen another hand. Forgive me. Okay, all right. Kasha, Prof. Kasha.
Mr. Hackman,
Hmm.
please, does it mean you can't repeat the liberty values?
Yeah, you can, because if you repeat, okay, you are going to get the same thing. You should know the result you are going to repeat.
Yes, please.
You get the point?
Yes, please.
So before if you have used it, then it means it will end up giving you the same result if you use it again.
Okay, thank
All
you.
right, okay. But take note, this wasn't a liberty value. This was a value that, okay, we got from the linear. So this one is an automatic value. Okay, but the others will be the liberty values. The one that we didn't use any of the factors to generate.
Yes, please.
Okay, all right. Okay, so now you come to, okay, plus. Okay, so plus, let's deal with this one. This will give you 2b plus c. Am I right? So then it will be times 1, but that will give you the same 2b plus c. But for the purpose of explanation, I'm going to remove the inner bracket so that I will get what? 2b plus c. Then this one will give you 1. But I said I am matured, and you should be matured. You know that if this is 1, okay, if you multiply, you end up getting this. So instead of writing the bracket here, you ignore. So it means now this will be your next step. This implies that I'm going to get 5, okay, will be equal to 5a, okay, plus 2b, okay, plus c. All correct. Is my point well made, my professors?
Yes, sir.
Okay, so again, you can see that here is the case. None of your letters, okay, vanished. Your unknowns, A, B, C, vanished. You are not worried. You are not bothered, okay, because you know 2 of the unknowns. So once you know 2 of the unknowns, you can use it to find a third unknown. Okay, so you know the values of what? A and C. So you can use that to predict your B. All correct?
Yes, sir.
Okay, so at this point, I am going to write, this implies that, okay, I'm going to carry out the substitution. 5 will be equal to 5a. A is known, 1. Okay, plus what? 2b. B is not known, so that's what we are looking for. Then plus c. C is 2. Okay, so what do we get? 5 will be equal to 5 plus 2b. Okay, then plus 2. Okay, I could have skipped the step. 5 plus 2, then move that one to the side. So this will give you 7. You move it to the side. Okay, so that will give us what? 5 minus what? Minus 7. So that will give us minus 2. Am I right? So you write it again before you divide. So 2b is equal to, okay, minus 2 over 2. Okay, over 2. Okay, so on this note, I think it didn't go there. So let me see whether I have a space to continue. Yes, I have a space. So I shouldn't have even squeezed. But we can still go and continue over there. So B will be equal to which value? Your continuation. B is equal to, I'm waiting.
-1.
Okay, B is equal to -1. So now we have the values of all the unknowns that we needed to have our partial fraction, okay, written out completely. Okay, or exactly. So A, B, C, we know the values. So at this point, you come and draw your conclusion. So therefore, okay, what you were asked to resolve, okay, which is 3x minus 1 over, okay, x minus 1 times what? X squared plus 1. And extend it to cover everything, both in your numerator and denominator. Okay, so it's equal to, so let's go and see whether we can do direct substitution or we have to, okay, think a little. So the identity here, A over by A, its value, is it positive? It's positive, right? So we can start with the first term here. I hope you are with me. Okay, so let's go and start with it. So it will be A over, so A, which is what? 1 over, okay, we said x minus 1. Okay, then plus, okay, so here we need to think a little for the second, okay, part. Let's go and check. Okay, it will be bx plus c. Bs plus c. But what is b? -1, am I right? Hello, -1.
Yes, please.
And C gave us a positive value too. So at the normal circumstance, we're going to write -x, -1 will be there. They don't write a 1, x. Okay, then what? Plus 2, am I right? Sitting in the numerator, then all over your x squared plus what? 1. Am I right?
Yes, please.
Okay, however, remember the advice. If you have a positive term and a negative term, so the numerator, I have a positive and negative, so I'll write a positive first. So that's what I'm going to. So instead of writing minus x plus 2, okay, I have to write that as what? My numerator, I have to write it as what? Who can guide?
2 minus x.
2 minus x. So that's the matured way. I hope you are following my professors.
Yes, sir.
Okay, so 2 minus x all over, okay, your other factor, which is x squared plus 1. You are done. All correct, my professors.
Yes,
Yes,
sir.
please.
Okay, so now I'm going to walk you through the alternative one. The solution is there. That is using the method of comparing coefficients. So we'll see, okay, which one is involving. And, okay, the one that's in this situation, any of them goes. But I've told you, for me, I always use the cover up because I'm expert. I know how to use the Liberty values. Okay, so quickly, the alternative method, okay, you do everything from, okay, up to this. So up to this step, it is here that your method will change as to how to find your introduced letters A, B, C. Okay, so here, let's go. At this point, if you want to use the method of comparing coefficients, you need to expand the side, combine like terms. So that's what I did here. I combine like terms and I come and compare coefficients. So the s squared, the coefficient there, okay, if you come here, there is no s squared. So it means the coefficient of this s squared here is 0. So it means the a plus b here should be equal to 0. Okay, please listen carefully. This time we are going to encounter a different set of equations to work with. Okay, all right. So again, then if you come here, it will be c minus b, coefficient of x, should be equal to coefficient of s here, which is 3. And last but not the least, okay, your constant here, a minus c, should be equal to the constant here, which is minus 1. So at this point here, you can reduce, you label it. Not containing brackets, fractions, you can reduce, you label it. Same for this one. So if you look at this, you can see that you introduce 3 unknowns. So if you want to use the method of comparing coefficients, you should know right from the start that because you introduce 3 letters, okay, you are going to at least generate 3 equations before you'll be able to find the values of each of these letters. Okay, so now, okay, we've generated 3 equations. Okay, remember, in one of the situations, okay, you were taught how to solve, okay, equations simultaneously with 3 unknowns. I think even in our test, we had a situation like that. True or false?
True.
True. Okay, and take note, anytime you have an equation with 3 unknowns and you realize that all the equations, each of them contains the 3 unknowns, okay, there is a way. That is the normal way. Okay, there is a way in dealing with it. You said, I asked, and you people told me that you take one set, okay, or a pair of equation, eliminate one of the unknowns. So let's say if the equation contains x, y, z, take the first 2 equations, eliminate maybe y. Come and take the next equation or another pair of equation, eliminate the same variable that you eliminated in the first pair. So you eliminate y. Because if you eliminate y in the first pair, your resultant equation will involve only 2 unknowns. If you eliminate y in your second pair, your resultant equation will also be in x and z. So you now get 2 equations that you have generated with 2 unknowns, which is your comfort zone. Go and solve for each of these unknowns, then later, okay, use the 2 values to find the third unknown. So that's what we are going to do here. But here, it is not that situation, a special situation. If you look at this equation, please listen carefully. Okay, you know my questions are carefully selected. Okay, I've realized that you've not encountered this issue. So I have given you an example that will bring in this, okay, critical situation and how to deal with it. If you take the first one, okay, the first equation contains A, B. In actual fact, your letters are A, B, C. The first equation does not contain one of them, which is C. All correct. Your second equation does not contain one of them, which is A. Your third equation does not contain one of them, which is B. So you don't have even a single equation containing all your unknowns, A, B, C. Okay, any equation, one is missing. And when you have this situation, this is how you deal with it. Okay, fix one of the equations. Indirectly, if I say fix, it means pick one of the equation as a guide to help you eliminate in the other equation that you are going to consider. So here, this is what I did. I am going to pick equation 3. So if I pick equation 3, what letter is missing in equation 3?
B.
B. So it means I have to go and work on equation 1 and 2, the other 2 equations, and eliminate the letter that is missing here. So the letter that is missing here, you said is B. So it means I have to eliminate B here. Is my point well made in these two equations? And if I want to eliminate b in these two equations, look at the b. The sign here is plus 1. The sign here is minus 1. Okay, so it means I can easily add these two equations to eliminate what? The b. All correct. Is my point well made?
Yes, sir.
Okay, so I'm going to add. So that's why you have equation 1 plus equation 2. So that will be a plus b, which is your equation 1, then plus equation 2, which is c minus b. So you can see that this minus b will cancel this b. So in effect, we are going to get a plus c. That's what is here. That is for this side. Okay, for this side, which will be your value side, you equally add. So it will be 0 plus 3, and that will give you 3. Should I come again, or my point is well made?
Please come again.
Okay, so okay, someone said I should come again. So I'm adding these two equations. As for that one, you get it. Is that not it? You are adding
Yes.
these two equations. So if you are adding, okay, you add corresponding size, okay, like size. So a plus b, your latest side, okay, plus this. So I will add this and this. So it will be a plus b, then plus this, plus c minus b. So a plus b plus c minus b. The a will be there. Okay, the b, you combine like terms, plus b minus b. Okay, the b will go. That was your intention. It must vanish. Then plus your c. So that's how come you have a plus c here. Then you come and add the side too. Okay, the value side, which is what? 3. Is my point well made now? Hello?
Yes, please.
Okay,
Yes,
so at this point, you should know, wow. At this point, you should know that your resultant equation is in which letters? A and C. And you can see that it contains the letter, okay, or the letters that, okay, you have in your third equation that you use to, okay, decide, okay, what to do in the other two equations. So you now come and solve equation 4 and equation 3 simultaneously. So it's like now you have two equations with two unknowns, your comfort zone. You've taken the question to your comfort zone. So in order to solve these two, okay, I can eliminate what? C by adding. You can equally eliminate A, but you have to subtract. Okay, so if you eliminate A, your result will be in C. If you eliminate C, your result will be in A. But I can easily eliminate C by adding. So it will be equation 3 plus equation 4. So it will be A plus A. That will give me 2A. Then minus C plus C. That will give me 0. That was my intention. I've eliminated C. Then I will get minus 1 plus 3. And that will give me, okay, positive 2. I write it again in divide. So A will be equal to 1. All correct? Okay, once I know A, I can come and find my C in either equation 3 or equation what? Equation 4. But I use what? Because I will need A to find my C, I label this as equation 5. And again, I'm repeating again, don't write put. Okay, if you want to write putting instead. But I've told you it's not even necessary, so don't let it cost you any marks. Okay, if you want to write don't write substitute. If you want to write substitute instead, write substituting. Okay, however, again, I've told you to avoid that. So straight away, you just come and write, label your equation that you want to substitute. Okay, so you will just write 5, which is equation 5, into 4. And I've told you, don't write equation this way. I don't know why some of you, okay, simple instruction, it's difficult, so don't write equation this way. It's not universally accepted. Equation 1, just do this. You've labeled, it's read as equation 1, into 4. Okay, so that means wherever I see A in equation 4, it is 1. So that will give me 1 plus C is equal to 3. I can solve for my C. C will be equal to 2. Again, I will need my, what do you call it? I can use my A to find the B, okay, in equation what? Equation 1. Okay, or someone can use the C, the value of the C to find the B as well. But I decided to use A because, okay, of this equation, it doesn't. So equation 5, which is the same value for A, into equation 1, I'll get 1 plus B. Oops. Okay, I'll get 1 plus B is equal to 0. Solve for my B. So at this point, I know A, B, and C. The values that I had in the previous, okay, one will be the same values here. Okay, so it means my substitution and my conclusion will be the same. Is my point well made, my professors? So you can see that,
Yes, sir.
okay, the reason why, even with this one, if your simultaneous equation technique is not strong, you might struggle here. Though we usually say that this is the convenient approach because all your factors are not linear. But the other one, you can see that, okay, we didn't solve equations, major equations simultaneously. Okay, though we did it, okay, indirectly because we were substituting values. Okay, we didn't have the situation directly to deal with. That's my point. So, however, if this one sits well with you, please adapt. Okay, otherwise, I will advise going forward. That for me, I'll always use the cover up method. Always. Okay, all right. So, on that note, okay, this will be the solution to the B, similar to what you have there. But you go for your water break. When you come back, I'll walk you through this. Okay, in this case, you can see some values here which are not pretty. So a particular situation that I want you to be mindful of and how to deal with it. Okay, so your water break. All right, okay, at this point. Okay, so welcome back from the water break. Okay, so now from here, okay, we are going to look at the B. Okay, the B, I'm going to handle it from the method of comparing coefficients. I will ask you one or few questions here, other that I would have skipped. Okay, because we have a situation here. I want to be convinced whether you've understood the concept in dealing with this. So everyone should be ready. The question I can throw it to you, or I can make it general. Okay, so as usual, that's similar to what we just did. Okay, however, this time round, I'm using the alternative method as my first method, which is a method of comparing coefficients. So here, linear is not factorable. Quadratic is not factorable. So it means I can straight away write the identity. This non-factorable factor will give me a fraction, okay, with that factor sitting in the denominator. Okay, so linear, its numerator will be a constant. This non-factorable, okay, denominator will be the denominator of my second fraction. But because this is quadratic, the numerator, forgive me, the numerator will be linear. So just as explained now, you come and take the LCM. Okay, you know this will go into the LCM, s squared plus 2 times n times a. So the a, because it's a monomial, it's not necessary to be in brackets. S squared plus 2 is a binomial, you put it in brackets. Okay, then this will go into s squared plus 2 will go into your denominator, s plus 1, then times the bs plus c. So bs plus c, okay, and the s plus 1 that you are going to multiply, each of them is a binomial, it's more than a term. So you put each in brackets to maintain the meaning. So at this point, you come and equate the numerators. So that's what we have here. And I've told you don't write equating the numerators. It's not necessary. So at this point, what do we have? We are going to, just as you have here, we are going to use the method of comparing coefficients. Okay, so at this point, you expand, okay, which is what is done here. Combine like terms. So this is what we have here. Okay, s squared, as squared plus bs squared. You add the coefficient, so a plus b in bracket, then attach the s squared. Okay, the x2, you come and do same. Bx, okay, plus cx. Coefficient you add. So b plus c, then attach then the constants will be 2a plus c. So at this point, comparing coefficient, you can see that there is s squared term here, there is no s squared term here. So it means here the s squared term, the coefficient was 0. So a plus b here should be equal to 0. Okay, same, there is no x term here, so b plus c, coefficient of the x term to the side will be 0, so 0. Then your 2a plus c will be equal to the constant here, which is 1. Point well made, my professors. Hello, is my point well made?
Yes, sir.
Okay, very good. So at this point, again, you've generated 3 equations, okay, and you have 3 unknowns, so at least you have to get at least 3 equations. So a plus b, first equation, one of the letters unknown, missing c. Second, one missing a. Third, okay, one missing b. So with this one, okay, remember the trick. Take one of the equation as a guide to help you eliminate one of the variables in the other 2 equations. So with this one, okay, let me see. Which equation are we going to pick? Okay, so I decided to pick equation 1, okay, as my equation that is going to help me, okay, with the elimination. So if I fix my eyes on what? Equation 1. Okay, keep it. Equation 1, there is no C. So the other two equations, which will be equation 2 and 3, I have to eliminate C. Is my point well made?
Yes, sir.
How somebody can also fix equation B. Okay, if you fix equation B, it doesn't contain A, so it means you have to come and eliminate A in equation 1 and what? And so fix your equation 2. It means equation 2 doesn't contain A, so you come and eliminate A in what? In equations 1 and 3. But you can see that eliminating A in equation 1 and 3 will be a little involving, because you have to multiply one of the equations by 2, which is the first equation, before you can directly eliminate. But the other one, if you fix A, you can directly eliminate C without multiplying any of the two equations. So always check which one would be ideal to fix. Okay, ideal in the sense that if you fix it, working on the other two, okay, it will be less work. So now I've fixed my equation 1. Okay, so I'm going to use equation 2 and 3. C is missing here, so 2 and 3 I can eliminate was C. But because the sign for the C in 2 is plus 1, this is also plus, I have to subtract to eliminate. Is my point well made?
Yes, sir.
Okay, so it means, so now what do? I am going for equation 3 minus equation 2. Somebody can do equation 2 minus equation 3. Okay, it doesn't really matter. However, this is what I am going to do. I always want my A term, which will be usually my first term, to be positive. So that's why that's informed if you come and subtract 3 from 2, the A will be negative. So by that, this is what I have. I'm going to. So those of you who can do that mentally, as your rough work, you can do this. You can see that you are subtracting. So it is, we said equation 3 minus equation 2. So it will be 2A plus C minus, I'm subtracting only the side. So minus, because I have a binomial, I'll put it in brackets. If you fail to put it in brackets, you are doomed. So in this case, I'd rather get 2A plus C, then minus B, then minus C. So the C here will take care of this C. Okay, so in effect, you get 2A minus B. Is my point well made?
Yes, sir.
Okay, so that will be equal to, as for your normal side, when you are subtracting, it's very easy. We said the equation was 2 from 3, so it will be 1 minus 0. So 1 minus 0 will give you 1. So at this point, you can see that your fourth equation here, your equation that you have here, contains A and B, which is the same as the equation that you fixed your eyes on to work on the other two. So here you can easily eliminate B in equation 1 and what? 4. Okay, by adding. So equation 1 plus equation 4. That will give you A plus 2A, that is 3A. Then the B plus B plus minus B, so that will go. That was your intention. B has been eliminated. Then you get 0 plus 1, which will give you 1. So you write it again before you divide. You get A to be equal to 1 over 3. Not pretty, but no cause for alarm. Okay, we can still work with it, and we must work with it. Okay, so what do? You come and substitute, because you will need the A to find your B. Okay, either in equation 4 or equation 1, the one that you were solving to find your A. So I will label this equation 5 and go and write equation 5 into equation 1, because I can see that between 1 and 4, this is prettier. So I come to this. So wherever I see A here, it is minus 1 on 3. So minus 1 on 3 plus B is equal to this. Then I come and solve for B. So some of you will multiply through by 3, but it doesn't really, it's not necessary. So just move this one to the side. That will give you your B. Because the B, the coefficient is 1. Or even if it was negative 1, I would have rather moved the B to the side. So B is equal to minus 1 on 3. But you can see that before I can find my C, okay, it's either I substitute B into equation 2 or I substitute A into equation 3. But substituting A into equation 3 will mean more work because the coefficient here, Okay, so in that case, what do? We substitute equation 6, which is the b value, into equation 2. So that's what I did here. Minus 1 on 3 plus c is equal to 0. So again, c will be equal to, you move this one to the side, positive 1 on 3. All correct?
Yes, sir.
Okay, any concerns at least up to this point before we come to our conclusion? Okay, because if your values are wrong, your conclusion basically will be useless. So if you don't understand how we got the values, you need to talk. You know, always I give you the opportunity to do this. So if you don't grab it, you should know. Okay, all right, so now what do we have? We are going to get this. Okay, so we are going to substitute, okay, into this. A, was A positive? Yes, it's positive, so we can start with A. Do the direct substitution. B, was B positive? No, it was negative. C, was it positive? Yes. So again, just like the other one, we'll swap these two terms in this fraction. Is that clear? We are thinking before writing.
Yes, sir.
Okay, so it will be A over S plus 1. A is 1 over 3. Plus, okay, it will be BS, but because B was negative, we said we are not going to write that one first. We write the C, which is positive. C is 1 over 3. Then minus your BS. B is 1 on 3. So it was minus 1 on 3. Then what's your X? However, we cannot end here. Okay, you don't end with a fraction containing more than one division bar. So you cannot have 1 over 2 all over 3 and end with this. Maybe S is equal to this and end, because this contains 2 division bars. One here, one here. It shouldn't. It should always contain 1 division bar if possible. Okay, so again, this is what we are going to do. Remember, I've told you this and I'm going to repeat this. Maybe we have students here who were not part of that lesson. Anytime you have this simple algebra, in math, if you have A over B all over C, okay, this will be the same as, keep your numerator of the numerator, which is your A. The denominator of your numerator will come and multiply the denominator of your original, okay, denominator. So that will give you a BC. And obviously, this is no magic. It's coming from the fact that if I have A over B all over C, I know that this is equal to A over B divided by C, which is equal to A over B times 1 over C, which gives you A over BC. So somebody who doesn't know this, the person must go through this, which will not warrant any marks anyway. So the denominators here will come and multiply. So that's what informed my decision. So if I have 1 over 3 all over, okay, x plus what? 1. Okay, this will be equal to, remember my numerator, my overall fraction, this will still be numerator 1. And the 3 will come and multiply this. But because this is binomial, the 3 will be out and you put the x plus 1 in brackets. Is my point well made?
Yes, sir.
Okay. All right. Somebody who doesn't know this, you can still use this approach. I'm guiding you before, so it's better to play it safe. 1 over 3 to be 1 over 3 divided by, okay, x plus 1. But because this x plus 1 is more than a term, do it over 1 so that it will be a single fraction. Because if you write it this way, in any case, this is rough work. But if it's a major work, if you write it this way without, okay, writing the over 1 or putting this in brackets, you are in trouble. So in this case, this will be 1 over 3, then times 1 over, okay, x plus 1. So you know that the 1 will multiply, give you 1, then over 3 into this, but don't expand. Is my point well made?
Yes, sir.
Okay, then you come and do same here. Okay, so with this one too, this 3 will come down, this 3, but take notes. At the normal circumstance, if you are mature, you know that because the LCM in your numerator, okay, they are the same. The denominators in your numerator, okay, terms that you have, they are the same. It means the factor that will come and multiply the denominator here will be the same, which is 3. Okay, so I'm going to clear that. That is a little technical. I'm going to clear what you have here and to create more room for that explanation. If you get it, any question, you should be able to relate. Please, so far, so very good.
Yes, please.
Okay, very good. All right, so now let's look at this one as well. Then I will give you a major advice, okay, as to how to always deal with it maturely. Okay, so let me pick my pen. Okay, all right. So what we have here are the normal circumstances. Before I can change this division bar to the division symbol, I need to write my numerator as a single fraction. Before I can change this bar to the symbol, remember order of operation. So my numerator, denominator must all be single fractions. So here it is not. So writing my numerator as a single fraction, the LCM will be 3. Okay, then it will be 3 will go into, so I will just get 1. You know, once the LCM, the denominators are the same, my fraction will be 1 minus, okay, x. Do you agree? As my numerator, I'm talking about only this one.
Yes, sir.
Okay, then divided by, it will be divided by the whole of this 1 over 1, which is the same as times. I'm dealing with it maturely. Times 1 over x squared, okay, plus 2. Do you agree? 1 over the reciprocal. Okay, so
Yes, sir.
you can see that now this will give you 1 minus x all over 3 times that, but don't expand. X squared plus 1. Because when they are in the factorized form that you can see, if something can cancel. So that's exactly what I have here. Is my point well made, my professors?
Yes, please.
Okay, so please take note. If your denominators here were not the same, then you have to rather, okay, write this as a single fraction as your rough work. You get a common denominator. Your common is, assuming maybe it was 1 over 2 minus 1 over 3x. So here, this will rather give us 6. Okay, then this gives us what? 3, okay, minus what? Minus 2x. Am I right?
Yes, please.
So it is this 6 that will come and multiply, okay, the denominator here. And the numerator now will be 3 minus 2x. Is my point well made? So if necessary, do this as a rough way. It's simplification if you are not matured, as a rough way, just as I've guided you here. And, okay, draw your conclusion as such. Point well made, my professors.
Yes, please.
Okay, great. So that will be it for this. And this one is the cover-up method or elimination method or approach to what you have here. You do the same thing up to this point. So it's at this level point or step that you use the cover-up. You know you already have one linear. So that is not a liberty value. That is a constant value, a value that you need to work with. Okay, so here if s is equal to 0, so if s plus 1 is equal to 0, s will be equal to minus 1. So you go for if s is equal to minus 1. You do that and that will give you, okay, a to be equal to 1 over 3. So already we know one of the letters. Okay, unfortunately your other factor, okay, is not linear. So you can't set it 0. So we are now going to rely on our liberty values. Is my point well made?
Yes, sir.
Okay, so your first liberty value that I said you should go for should be
0.
0. You haven't used 0, so you can use that liberty value. Okay, so you can see that working with 0 is always the easiest. That's the more reason why I said if you haven't used it, use it. Okay, so if you carry out the substitution and simplify, you come and get this equation. But because you know A, you come and substitute the A and you find your C, which will also be this. Okay, from 0, which other liberty value do you, or what's the next liberty value per my advice?
1.
1. Have you used 1?
No, please.
Okay, so it means we can go and use it. You get a point now.
Yes, sir.
Okay, so you carry out your substitution, you get this. If you solve, so with this one, you can see that none of them will vanish. So you get your 3 letters there, but you know 2 of them. You go and substitute the value of C, go and substitute the value of A here, then you simplify. You end up getting the same value, okay, for the B that we had using the comparing coefficient. So the B will be minus 1 on 3 if you continue. Okay, so continue and verify. Is my point well made? Okay, as for the substitution and simplification, I don't have to do it for you. So that's why I said you should continue, just to save time. All right, so now let's go and look at what? Question, okay, 3. Oops, okay, so this is it. Quickly, okay. First question, remember, so our next worked example question, write the following as partial fraction. So you know, we don't have to end at the identity, we have to go beyond the identity. Okay, so now, solution, the first thing that you write, major question number 3, minor question number 8, given. Okay, so what are we supposed to do here? Okay, we have linear, okay, factor, but it's repeated. Okay, so this linear factor is not factorable. It's repeated. We can straight away write the identity because we know how to deal with what? Repeated, okay, factors, what? Identity. All correct. Okay, so if you are writing the identity, what will you write? This will be identical to. Already we know that this is proper. That's the first question. Okay, numerator degree 1, denominator degree 2. So proper. Okay, so how would you write the identity? The power here will determine the number of fractions. Okay, so power 2. So it means one fraction, the denominator will be x minus 3 plus the second fraction. What do you think will be the denominator?
X minus 3.
That's all.
All squared.
All squared. Very good. My professors, I hope you are following. Remember, we've done enough. So if your identity is shaky, you have the videos available. Go and use that to revise, to put you back on track. Because if your identity is shaky, just like I said, okay, you will struggle because that is key in resolving. So this is linear. Okay, numerator will be a constant. Your repeated factor is also linear. Numerator will be a constant. So at this point, single fraction all the way. Okay, so what do you think will be the LCM? Are you going to multiply? No, even this question I've told you, don't struggle. It will always be the same as what your factorable expression in the denominator. So that will give you x minus 3 all squared. Okay, obviously you know that x minus 3 is a factor of x minus 3 squared. So this then becomes just as if you have 1 over 2, okay, plus let's say 1 over 4. Okay, because 2 is a factor of 4, 4 becomes the LCM. Is that clear?
Yes.
Yes,
Okay,
please.
so now this will give us, okay, the number of times this will go into this, okay, and it will be x minus 3 all squared over x minus 3. You know that this will cancel one of them. So you'll be left with x minus 3. So it will be a into what? X minus 3. Then plus, this will go into this 1 times b, so plus b. All correct?
Yes, sir.
Okay, so at this point, now that we've written the single fraction form of this, we are going to equate the numerators. So that will give us, this implies that s plus 1 should be equal to a into x minus 3, oops, okay, then plus b. All correct. Okay, so here, cover up method. Remember I've said, okay, so you have a linear factor. So you have to set this linear factor to 0 and solve for x. So x will be equal to what? 3. So I'm going to get if x is equal to 3. That's the first, okay, value. Sorry, did I write 1? Okay, 3. So we are going to get, okay, 3 plus 1 will be equal to a into what? 3 minus 3, then plus b. Okay, so on this note, we get 4 is equal to 3. This will go because we covered up this plus b. So you know the value of b. Don't come and write b is equal to 4. It's the same thing. So take note of that. All right. Okay. So let me write my b well. So now, okay, you've exhausted your, what do you call it, your value, critical value that you could substitute. Now you come to your liberty value because you've not found everything. So you go for, as usual, if x is equal to the first liberty value you haven't used, x equal to 0. So what do we get? 0 plus 1 will be equal to a into 0 minus 3, then plus b. Okay, which gives us 1 is equal to, okay, minus 3a, okay, then plus b. All correct?
Yes, sir.
Okay, we know the value of what? Of b, so we can use that to solve for. So I'm going to write maybe, okay, 3a is equal to, I am going to do change of subject before substitution. You can substitute before change of subject is allowed. So A will be equal to maybe B minus 1. So I'm going to get 3A will be equal to, okay, B, which is 4, minus 1. So 3A will be equal to what? 3. So 3A is equal to 3 over 3 over 3. Okay, so A will be equal to what? 1. So at this point, I can draw my conclusion. Therefore, okay, x plus 1 over x minus 3 all squared, its partial fraction will be equal to A. Did A give us positive? Yes, positive. So I can start with it. 1 over x minus 3. Then plus your B. B is also positive, yes. So plus 4 over x minus 3 all squared. Point well made.
Yes, sir.
However, and I repeat, however, okay, whenever you have this kind of situation, a rational function where the denominator contains a linear repeated factor only one linear repeated factor with no other factor attached. If you look at this, you can see that your denominator here is a linear factor which is repeated with no other factor attached. Is my point well made?
Come
Okay,
again, sir.
you can see that this denominator contains only a linear repeated factor. Okay, no factor is attached. Okay, this one, you can see a linear repeated factor, but there's another factor attached. Can you see that?
Yes, sir.
So it means what I just said is not applicable to this. It's only applicable to a situation where there is no, okay, other factor standing with your repeated factor, linear factor. So when you have that situation, see what is going to happen. We are going to look at that as an alternative, okay, method. When you have this situation, please listen. Okay, our time is almost up. Please listen. Okay, but I will have to take my time and walk you through this. Okay, because any time you encounter this is the ideal method. We use what we call the substitution method. And by that, this is what you do. Your repeated factor, or your factor that is repeated, represented by a letter. Any other letter apart from X and Y. Okay, or you can even use Y. Okay, but I am going for U. So let's, okay, the letter U be equal to your repeated factor, which is X minus 3. Is my point well made?
Yes, sir.
Just listen. Okay, so if your x minus 3 is U, then it means the denominator, if you substitute, will be U squared. Do you agree? Hello, please, do you agree?
Yes,
Yes,
please.
please.
So here,
Yes, sir.
we are changing the x here in the original question to U. The U is going to make our work very easy. So since the denominator x has vanished, the numerator x should also vanish, so that your expression that you have on that side, okay, will strictly be in U. So by that, this is what you do. Once you know the connection between, okay, x and U in terms of U, you should know the connection between x and U in terms of x. So from this, okay, representation, is it wrong for me to say that x will be equal to U plus 3?
No, sir.
Okay, so mathematically right. So it means wherever I see x, I can get its representation in terms of U, so that everything will be in terms of what. So I will now write, this implies that, okay, whatever that I was given to resolve, which is x plus 1, okay, over x minus 3 all squared. Please listen carefully. Will be equal to, per my substitution, x minus 3 is U, so I will get U squared, just as I've said. Oops. Okay, and your numerator, we said is x plus 1, but what is your x in terms of U?
U plus 3.
Okay, so it will be U plus 3, but that is not all plus 1, because this is only representing your x. So let me put it in bracket for you to know that you are substituting. But when you mature, it's not necessary. Is my point well made? Okay,
Yes,
so
sir.
now I can write this is equal to, listen carefully, it's interesting. Okay, so that's one thing I like about math. Okay, so you get U, okay, plus 3 plus 1. So can I say that this is the same as u plus 4 in my numerator all over u squared? Do you agree?
Yes, please.
Okay. Now you can see that this is a single fraction in terms of u, but the question asks you to write what you have there as partial fraction. So I know this is the same as, okay, the partial fraction in terms of u will be the same as u over u squared, then plus 4 over u squared. Do you agree? If you have a plus b all over c, we all know that is the same as, okay, a over c plus b over c. So that's what I've done here. I haven't done anything special. So this is going to be equal to, okay, u over u squared. We know that will give us 1 over u. All correct. We can reduce.
Yes, sir.
But the 4, okay, we cannot reduce that. So, sorry, 4, I wrote u again. Forgive me. Okay, initially I almost wrote u here. So let me clear that and do that. Okay, it's 4, not u. Okay, so 4 here. Okay, 4 here as well. So 4 over u squared. Okay, now u has served its purpose. So since your expression came in x, your conclusion must also be in x. So at this point, I am going to substitute the u back. So therefore, okay, my x plus 1, okay, over my x minus 3 all squared, okay, will resolve into 1 over u. So 1 over my u is what we said is x minus 3. Then plus 4 over u squared. U is x minus 3, so x minus 3 squared. Let's go and check whether we had the same result. Is it not the same?
Yes, sir.
Is it? Okay, so you can see that between the two, which one will be ideal? Between the two, which one is ideal?
The second one.
The second one. So anytime you encounter this situation, okay, I am going to plead with you and advise as usual. Okay, immediately you are dealing with any rational function and you realize the denominator contains a repeated factor with no other factor attached. Always use this approach. Okay, the substitution approach. Okay, so quickly, I will use this approach in dealing with this, and that will be it for, okay, today's meeting. Okay, so we have just a minute or two to round up. So the same here, you can see that the denominator contains only a linear repeated factor. Okay, so with no other factor, so we can use the substitution. So please listen carefully. So let u be equal to what? Your linear repeated factor, which is x minus 2. And the let capital letter you are starting. So this implies that x will be equal to u plus 2. So that's okay. So now here, I'm mature. So I'm starting with therefore. If you write implication, you will later go and draw your conclusion. So therefore, what I've been asked to resolve will be equal to the substitution. It will be 2 times what? X, but x in terms of u is u plus 2. Okay, you put in brackets minus 1 all over u cubed, because this is now u. This is now u. Okay, then you come and expand. Okay, then combine like terms, if any. So 2u plus 4, then minus 1 all over this. So this will give us 2u, 4 minus 1 will give you 3 all over u cubed. Is my point well made?
Yes, sir.
Okay, and at that point, what do? You now come and split. So you get 2u over u cubed plus 3 over what? U cubed. But this can reduce. The u will come and cancel one of the u's in the denominator. So you get 2 over u squared. Then plus here, you can't reduce your u's. So you maintain it. And you come and carry out your substitution. So this gives us this result that we have here. Point well made. So this will end. However, if you go the normal route, look at the work that you will do, the volume of work that you are going to do here. So in that case, your identity alone, look at what we are going to write. Because the power is 3, you have 3 fractions, okay, with this. The first one, s minus 2. The second one, s minus 2 squared. Okay, s minus 2 cubed, you end there. So you can see the volume of work, and you end up getting the same results. Okay, so take note. Usually it is ideal to go this route. Okay, So on this note, okay, thank you very much. Any questions? Okay, you use the same understanding. We were supposed to have completed this, but we couldn't. So you will continue. It's the same thing. But with this one, you cannot use that approach. Take notes. You can't use that approach. Okay, because there is another factor attached to your linear factor. So you can't use the substitution approach. So you have to go your normal routes. Okay, your LCM will be this. Come in, take that, and you know this will give you one fraction. This will give you two fractions. Okay, so the one fraction that will give will be this. The two fraction that this will give will be this. So in all three fractions, take the LCM, then you know how to proceed from here. Your liberty values, you can get, okay, two direct values, which will you get from this linear factor, okay, s plus 2. So s equal to minus 2, then s equal to 3. I decided to do the positive x, s equal to 3. Okay, then later you come and do s equal to, okay, minus what, 2. Then after that, you now go for your liberty values, and your liberty values, you start with s equal to 0, you generate, and that will help you get it. With s equal to 0, none of them will vanish. So you get your equation in terms of a, b, and c. You know a, you know c. You go and substitute, and you get your b. Then you later go and substitute, okay, the values that you found there into this. The one that is positive should be the one that you start with. So if A is positive, you start with A. Otherwise, okay, start with any of them that is positive. Point well made, my professors. Hello.
Yes, sir.
Are we all fine?
Yes.
Is everyone fine? Okay, so thank you very much. Okay, so please, I will share the, okay, let me end the class, okay, before I say whatever that I want to say. Okay, so God bless us all. Okay, and thanks for making the class very interactive. Enjoy your day.